Good morning, guys. Today I'm going to talk to you about moving plates. No, not these kinds of plates. I'm talking about continental plates. So when I was a kid, I used to look at globes and maps of the earth and I would wonder about the shapes of the continents and the shapes of the islands and how did they get these holes in them and what was going on with that. How could you explain it? It looked like it was a jigsaw puzzle that would just fit together. I found that fascinating. And I wasn't alone. People for a long time had been thinking these thoughts. In fact, since the 1400s, 1500s, 1600s, when we started the age of discovery and we're starting to send off ships all around the world in search of new places and new things, we were getting better and better maps. And as we got better and better maps, we got better and better ideas of the shapes of the continents. And other people were noticing, hey, it looks like these two would just fit together. But what could explain it? What could explain it? It looks like they'd fit together, but that's ridiculous, right? These are rocks. Rocks don't move. So how could you prove that this was something that this belonged here? So Alfred Wegener in 1919 comes up with this list of evidence that he found. So first, he noticed, just like you and I noticed, the map, it looks like these would fit together. So he said, okay, well, if they're going to fit together, then the rocks here should match the rocks over here. So he tested them out and he found out the rocks here actually matched the rocks that were over here. The specific type of rock that was here was matching the type of rock that was over here. Not the rock that's here, not the rock that's here, but matching the rock that's right there. So there was definitely a connection of similarity between rocks. Okay, so that's just one point of evidence. Maybe that's not enough. Let's think. What else would prove or lend evidence to this theory? Well, the next thing is if there were plants and animals that were living over here, when this was connected, there would be the fossil evidence to show that the same types of plants and animals that lived here were also living over here. So he looked at the fossil record and he found plants that used to live here and plants that used to live here that were the same. Same thing for animals. He found animals that used to live here that fossil record showed also lived over here. So now you got some strong points of evidence, and he presents his theory and everybody is very impressed with his evidence. They say, this is some solid evidence. I like your theory. I like your evidence, but the problem remains we can't accept your theory until you show us how rocks move. People were coming up with mad ideas like, well, maybe there was a big bridge of land over here that got eroded away in the meantime, and that was what connected them, and that's how you had different animals, but you had the similar rocks. Or what was it that was going? Like, did the rocks get like legs and walk away from each other? It wasn't until the 1960s that we discovered this amazing thing. It's called the Mid-Atlantic Ridge. And it is a jagged line that goes down the Atlantic Ocean and wraps around a lot of the earth. It's not just the ocean. But basically, this was a split in the earth, a place where the two parts of the earth were separating. This is the longest mountain range in the world. Over here in California, we've got the Sierra Nevada mountain range, and this is about 250 miles long. The Mid-Atlantic Ridge is a mountain range that is 40,379 miles long. Amazing. And not only is this a mountain range, it's not just a mountain range that's sitting there, I'm a mountain. But this is a mountain range that is pushing up and spreading out. Pushing up and spreading out. So when new volcanoes form and then they start moving off to the side and then move up and then move out and pushing up and moving out. And so this Mid-Atlantic Ridge is spreading apart at the rate of about 1 inch per year, which means that our Atlantic Ocean is getting bigger by about 1 inch per year. This evidence, discovering the Mid-Atlantic Ridge, was the turning point in accepting the theory of continental drift. This was something that started to show there's actually something going on deeper inside the Earth that is pushing, that is moving the continental plates.